So welcome back, ladies and gentlemen, here on the innovation stage at the EMO 2025 in Hannover. We are proceeding with our program with a very interesting topic, and we stay in the topic of artificial intelligence. And I'm super excited to hear the next speech because it's about how AI helps the machines to turn into self-optimizing systems. And honestly, at the moment, I can't imagine how this is going to work, but therefore we have a speaker here to explain us. So please welcome with me Sergey Altimbev, is that correct? More or less, founder and CEO of Ailoys, please.
Thank you and good afternoon. Today I will be talking about the two things. One, it's challenges which current manufacturers have with stability of manufacturing process, with supply chain challenges. And two, how nowadays industrial AI systems can help them to solve these challenges. Our mission is to solve the following challenges of manufacturers: the lack of skilled experts and labor. New engineers much more prefer TikTok business rather than going to industrial manufacturing. Technology improvement and storage, supply chain risk, and quality control and predictive maintenance. We are addressing this challenge by creating an AI brain. That's how we're marketing our device. We have a proprietary sensor solution which senses the process and can automatically adjust it. Few words about the solution. We're using so-called acoustic emission technology. It's small irradiation which appear when you deform the material, when you cut, when you bend, when you deform the material cell structure. In this moment, material irradiates small acoustic waves which we are feeling with our sensor. This technology combined with an edge device. With this edge device, we are able to prepare this data for our cloud performance. And later on, as soon as the machine training is finished in our cloud, we can compress the model, download it to our edge device, and then even tune the machine based on signals. Basically, we are building a digital twin of manufacturing process. We are scanning material certificates in order to understand the influence of the chemical composition into the process. We checking the manufacturing parameters such as feed and speed and spindle speed from PLC. And we accompany this with our so-called acoustical fingerprint. Basically, this kind of acoustic signature used to find the submarines by their noise they're irradiating. And here comes the real example, real use case, which we did with our partner Chiron Group. They're exhibiting in this hall. This is the luxury watchmaker from Switzerland, and this is the grooves, one of the most common defects on the surface. The thing is that raw materials, even though they are coming with the same standard, they have a slightly different chemical composition and therefore material properties. And very often when we fix a machine NC program, we see this defect. And that's basically how we solve it. We developed a plug-and-play solution, work with mostly PLC controllers, ABB, Siemens, Beckhoff, Fanuc, and we can talk with the controller of the machine. Basically, when we see the deviation after the training our machine learning algorithms on good processes, we can see the deviation. And beauty of the edge device that we can work in real time, unlike many of our competitors. The device working in a way like a baby learning first noises in his life. First, the baby learns his mother's voice, his mother's frequency. And then, as soon as baby heard some other voices, he starts crying. Our device, instead of crying, start doing root cause analysis in real time. And basically, we can not only spot the defect, we can also send a signal to the controller, for example, to reduce a spindle speed 10%, to reduce a feed, and bypass the dangerous scatter place in a raw part. That's our team. We combine material science engineering experience, industrial manufacturing experience, and of course AI and financial. That's our customers so far, and despite of a relatively young enterprise, we are only 1 year young. We're already working with some renowned customers in CNC and wire and drawing and additive manufacturing fields. As well as you can see in enterprise level, we do have a cooperation with Mitsubishi Materials. They are very interested because during the process, for example, this here, you can see how the different tools are working. And basically, we can build a digital twin of each tool and predict where exact tool can be broken. So we are addressing the problem of the tool change. And of course, around the hardware device, we build a software. We also understood that a small and medium enterprise not all the time have a budget to acquire expensive SAP or other ERP systems. Therefore, we build a combination of simple and understandable MES and ERP software where people can control their assets, they can control their part numbers, product catalog, material defects. And basically, the main feature which we are providing, it's a benchmark. Imagine that you are making a soup and you want to taste it. You can't till it's hot, and you don't have any indicator of the test. This is giving you indicator during your CNC process. And as soon as our AI agent, the small script which is installed in our edge device, sees some deviation, your quality assurance technician receive a signal that our AI agent spot this deviation. And then quality assurance technician can mark it as a defect or can say that it is normal. As soon as it's marked as a defect, it comes to our defect database, and next time when our AI agent see the similar sequence of the signals, it can proactively send a controlling signal to the PLC controller to avoid this defect. And basically, we are addressing the problem of uptime, so we increase overall equipment efficiency and we reduce scrap. Basically, we are turning your machine with our AI brain to self-adjustable manufacturing cell. Another example which we did recently for oil and gas manufacturer, this is the forged bars machining. And the forged bars on the surface, you have a highest hardness. You're coming to the center, you have a different hardness. But you, as a CAM programmer, you have to adjust your manufacturing cycles to these changes in the hardness. Our system does it for you. And basically, we address requests from the manufacturers to innovate in two cases. First of all, they sometimes need to change. They understand that they need to innovate or they need to solve a problem. And for this kind of problems, we develop 3 very simple solutions like a digital fingerprinting, real-time root cause analysis, and AI agents. Sometimes our customers request that as soon as certain defect appear, they need to send a signal to the conveyor belt, for example, to throw out these details or to do additional inspection. That's what can do our AI agents. And our value proposition is to help customers to increase performance, work on quality improvement, and to adjust new products. That's it. And if you are interested, please follow us in LinkedIn, ask any questions. Thank you very much.
Awesome, Sergey. Thank you so much. There are already a few questions, as I've seen, so let me ask them to you. The first question is, it's always interesting to see a new solution, but you are still startup, right?
Yes, exactly.
But is it already implemented anywhere?
Absolutely. We started cooperation with our partners at Chiron Group. They're exhibiting here in this hall, and we implement our solution already in their Micro 5, a new Micro 5 XL machine. Basically now, customers can order a machine with AI feature in it.
Very good, very good. What I found really interesting is that you rely on acoustic emissions, basically. So, but if we go now into different machine types and different production environments where you have different sound profiles, how can you ensure the quality?
First of all, a few words about environments. Due to the specifics, so basically we're listening these acoustic micro signals from the material being processed. So we are agnostic of any noise, any background noise in a factory floor. And then the next question is a very good one. Basically, you're right that we need to readjust our machine learning model to the new type of the machine. Therefore, our go-to-market strategy to work with OEMs like Chiron, like DMG Mori, to onboard the type of the machine, certain type of the machine, and then we can retrofit all existing customer base. But according to our latest developments, and due to the specifics of the acoustic emission technology, our device reading 10 million times the acoustic information. Basically, we need around 10 seconds to train our machine learning algorithm, and then it's adjusted to the new type of process. So basically, we are self-adjustable.
So you were talking about time, and there's one of my favorite questions by the audience, indeed. What is the return on investment timelines? I mean, you are promising reducing scrap up to 20%.
Yeah.
So when do I get my money back, so to say, with your solution?
I will give you example from the luxury watchmaking industry. Especially when you work with the precious metals like gold or platinum, some companies generate around 300,000 euro worth of scrap monthly. And we deliver our device based on subscription. It's cost starting from 1,000 euro per month per device. And basically, already less than few days, they pay off their device.
That's good.
And of course, we are concentrating in an industry where ROI can come faster. For example, titanium, it's aerospace and medicine. In Cornell, it's oil and gas and aerospace, and of course, precious metals and precision mechanics.
Very good. Last question from the audience. What is the biggest challenge for scaling your solution? Data quality, customer adoption, or integration into existing IT, OT systems?
A very good one. I think all the proposed answers, they play a role. I would say that's customer adoption, because the industry is very conservative, and therefore we in our, for example, fundraising challenge, we are looking for the investors who have a good industrial limited partners base, who can introduce us to the certain C-level. So as soon as the adoption of the innovation on the agenda of the C-level, then we don't have any problem. We need just a first trial, first pilot, and then customer believe. And of course, the adoption of the existing NDT system, it's also very important. Therefore, we are constantly building APIs to work with existing solutions. And basically, you can treat our device as a Apple home for industrial manufacturers. We can work with all existing NDT systems.
Awesome. Those have been the questions. Very good one. Thank you so much for being our guest. Excellent presentation. Big applause, ladies and gentlemen. Thank you so much.
Thank you.